first one I'm going to explain to you is this one going around the outside edge. Whenever you look at a bulb, and I'm going to show you a lighting facts from a bulb package in just a minute. That 5,000, the K right there stands for Kelvin, Kelvin. Okay. Kelvin refers to temperature. They actually, it's another measure of temperature outside of Celsius, Fahrenheit, Kelvin. It's a different measure of actual physical temperature. But in this case, it refers to light temperature. A 5,000 Kelvin bulb is considered daylight. They actually have bulbs that go up around 10,000 Kelvin. They're a blue light. They're very blue. I'll show you here in just a second.
How many kelvins is like a blue LED light?
What's that?
What if you had like a blue LED light? How many kelvin would it be?
If it's an actual blue LED light, like I've got one over here that I'll show you, when it's a blue LED light, it's a whole different thing because it's actually a color. This is a color temperature, and so it's different. I'll show you the difference. Okay. As we gradually get lower in kelvins, it goes to this. The most common bulbs that you will find, if you go to the hardware store, the most common bulbs you're going to find is daylight bulbs at 5,000 Kelvin and warm white at 2,700 Kelvin. Those are the two most common Kelvin bulbs. To get into the 10,000 Kelvin range, you're probably going to have to go order those online or go to a very specialty light store. To get into the 1,000 Kelvin range, which is basically candlelight, you're going to have to go to a specialty store. We do have some lights in here that I'll show you that are called amber, that are 2170 Kelvin, and they're very warm tone. I'll show you the range of this, but Kelvin simply refers to the color temperature of a bulb. I've got two identical bulbs over here, and I can turn these on for you so you can actually see. They look identical in every way. Unless you put on magnifiers and you start reading these are both Philips bulbs. They both have all their printing and everything in the exact same location on here. They're both 800 lumens, which means they're a 60 watt equivalent bulb, and we'll talk about wattage here in just a second. If you look on there, you see 60 watts equals 800 lumens. That's old school because that's when incandescent bulbs were about. So to get 800 lumens, you needed 60 watts of energy. These actually use 9.5 watts to get the same illumination. So they're very, very efficient. Okay? But if I turn one of these on, okay, that is a 2700 Kelvin bulb. That is a 5,000 Kelvin bulb. So you can see the color temperature. If you look at my face or you look at the table, the difference is pretty pronounced. Okay? They are identical when I turn them off. It's the light appearance that we're talking about. So 5,000 Kelvin, 2,700 Kelvin. So we'll look at some other bulbs as well, but the Kelvin just simply refers to light temperature. Now, when you start getting colored bulbs, all bets are off. That's a whole different thing. If they're actually tuned to a certain wavelength of color, then it's a completely different thing. All right, so Kelvin, everybody clear on that? The next thing is lumens. Okay, lumens is the measure of brightness. How bright is the bulb? A 1600 lumen bulb is going to be very bright. A 200 lumen bulb is going to be very dim. Okay? And we can fluctuate that now because we've got dimmer switches. Okay? And I'll show you dimmer switches here in a little bit. But the lumens simply refers to how bright the light is. A high lumen light is going to practically blind you. So you've got to be aware we're going to be critiquing these probably in a dark space like the figure studio. We always leave out of here so that we can focus solely on the light quality. And so we'll be in one of the classrooms or we'll be in the figure studio to critique these. And when our eyes are all adjusted, you know, our pupils are expanded, dilated to take in as much light as possible in a dark room. And then you pick on a 1600 lumen bulb that is bare, that you can see the bulb, it's not blocked in any way, and we're all going to turn into vampires. you want to be aware of that. So if you're going to have a bulb that is bare to your vision, that's not blocked by some other thing or diffused in some way, then you've got to be conscious that it's going to close people's pupils right down, and we're going to, because of the intense light. So you got to be aware of that. So 1600 lumens, that's high lumens. These light arrays out here in the sculpture yard, if you've ever been here at night and kicked those on, they're in the 10 to 13,000 lumen range. They're really, really bright. Okay? So intensity of light, lumens, color of light, kelvins. The wattage, that's kind of been blown up by LEDs. It used to be that a 40-watt bulb gave you 450 lumens, 60 watt gave you 800, and so on. So now they say, like on a bulb, if I pull a bulb out of the box here, and I've spent a lot of money on light bulbs for you, so that you don't have to go out and buy a whole bunch of bulbs. So this says it's an A19 E26 base. The E26 base is the base like this. These are all E26 bases. So if you're ordering a bulb online, and you don't need to necessarily say A19. You need to know the 26, that. So
wait, where's the top of it?
What's that?
Where's the rest of the light bulb?
That's a grow light. You put these in your window, in your house, in your basement.
Oh, it's for plants?
And police officers will probably want to ask you what you're growing.
Oh, I'm the kind of person who just likes plants though.
That's a very specific kind of grow light.
Oh.
I had to sit over in class once that made light and left one of the bulbs.
Wait, really?
Anyway, so wattage is different. Like this will give me 450 lumens. So this is what they would call a 40-watt equivalent bulb. So these are 450 lumens. They use, let's see, where's the wattage? 6 watts. So 6 watts instead of 40 to give you the same kind of light energy. The federal government has actually outlawed the sale of the incandescent bulbs in stores. You cannot go buy an incandescent bulb in a store.
But you can get one off the black market, maybe?
Possibly off of like people on what's the Facebook Marketplace or something like that.
Just because we're not allowed to have them, I'm not.
Yeah. So anyway, because they're super efficient, they don't last long, and they can be potential fire hazards. So anyway, so kelvins, color temperature, lumens. Is the intensity of how much electricity goes to that light bulb. I changed my whole house. My entire house is LED bulbs now. My electrical bill dropped, noticeably dropped, because I put all LED bulbs in. Because now I can have probably 3 rooms completely lit for what it would have usually taken me to light one. So anyway, so these charts should help you in your design thinking. So shapes of bulbs, color temperature of bulbs, where those color temperatures belong in a living space. Okay. Now, all of that is on this thing right here. So you see shapes of bulbs. You see color temperature. Okay. So kitchen, bathroom, home office, living room. So all of that is here. Then you've got colored lights right here that are completely outside of that Kelvin. Watts to lumens. This one right here is showing compact fluorescent, but it says compact fluorescent, halogen incandescent LEDs. But on nearly every light bulb package, there's a thing like this called lighting facts. Okay? There's one right here. So when you pick up a box of bulbs, you can look at it and you can see, okay, 450 lumens. The standard reading lamp should be a minimum of 800 lumens. Anything dimmer than that, I mean, you could read with 450 lumens.
So you'll get a migraine.
But it can cause trouble for your eyes. So typically, if you want a reading lamp, you're going to be about 800 lumens, 60 watt equivalent. Okay. So this one right here is 800 lumens. It's got a lifespan of 7 years, which tells me it's not incandescent, because incandescent bulbs don't have that kind of lifespan. Okay? The light appearance, this is a warm white right here, so it's 2700 Kelvin. It even tells you on the scale whether it's warm or cool. The energy used is 14 watts, and it also says contains mercury, so I know this is a lighting effects for a compact fluorescent CFL bulb like this, okay? Just by reading that. This one right here is 450 lumens, 13.7 year lifespan, 3000 Kelvin, so it's toward the center, but it's a little toward the warm side, and it's 6 watts. Okay? So you can go and look at any one of these. Sometimes if they're really tricky specialty bulbs, like this one's not going to tell you because it doesn't really fit into the standard category of lighting. But just about any bulb that you pick up a box like this. I've got a lighting fix of 250 lumens, cost per year to run this 3 hours a day. That's a standard that we use. 54 cents to run this bulb, 3 hours a day, 365 days. Okay? Its lifespan, based on 3 hours a day, 13.7 years. This one is off the chart warm. This is a 2175 Kelvin. So it's off of the chart that you can use, and the energy used is 4.5 watts. So when you pick up a bulb, you can look at the shape, you can tell how bright it's going to be, and you can tell what color temperature it's going to be just from looking at the bulb. You can pick up any of the bulbs, pull any of the bulbs out here you want, put them in and try them out just to see how things go, okay? So that is information that you need to know. Lumens, Kelvin, wattage, or wattage equivalent. Those are all important things to know. The next stuff that I'm going to teach you is actually going to be hands-on over here. Practical application knowledge. So you want to come gather around the table here. I'm going to walk you through. You're going to know more about electrical wiring at the end of today. Not than electricians, but better than 90% of the population. That's what I like to say. So, and a lot of this is just FYI, so that you know. I want you to be educated people, and I want you to know why we're going to wire a particular way. I will tell you right up at the start, for lamps, it doesn't matter the polarity that I'm going to wire into this. Polarity is kind of a weird word for this because polarity typically refers to DC, direct current electrical. Polarity is positive and negative. It's like your battery in your car, you've got a positive and a negative. You switch those, bad things happen, okay? In this context, if I switch up the polarity, what's called the hot and the common, if I switch those up in my process through here, it's not going to make any difference. But I want to show you how to do it right, because things that are wired professionally, like if you buy a lamp from some interior design store, it's going to be wired with this same kind of polarity in mind. Right, so I want to teach you how to do it. I want to show you why. I will tell you, if you mess up the polarity in your house when you're wiring using this kind of stuff, it's called Romex, it will shut down half of your circuit in your house. I had that happen. It was late at night, and I was in the dark, and I was wiring my home, and I crossed these two wires here on one of the units. It didn't blow my house up, but I noticed that some of my plugs weren't working down the way. So I'm like, okay, I probably miswired one of these, so I have this little plug I plug in, and it lights up. It tells me if my polarity is correct. And I just started going back through, and it's like, oh, yes, this one's been, and I pulled it out. Sure enough, I had crossed the wires on my plug. I straightened that out. The whole circuit started working. Okay. So, inside of your wall at your home, there are wires that look like this. I mean, there are wires that big old gnarly wires, like if you're running a heavy appliance, they get even bigger than this one. But this one right here is what's called a 10-3. It's got 3 wires carrying current. It's actually 2 hots. That red and that black are both hots, and 1 common and a ground. But you can get some really heavy duty wire in your walls. Like when I wired my dryer, my electric dryer, it's heavy duty wires going to that.
You say when I wired my dryer, that's just a thing that people always do. And they'll just hire someone who knows what they're doing.
I wired my entire house.
You're so cool.
From where the city ties into the last bulb screwed in, I wired my entire house. These are Romex, okay? And the thing I want you to see with both of these, they have something in common, is the color of the wires, the type of wires. We have a black, a white, and a bare copper wire, okay? Black, white, bare. In Romex, these are always bare, but they are coated with a piece of paper here. That's a protective shield so that if there's a crack in one of these, it doesn't jump an electrical spark across these. So I have trimmed I've just torn the paper off of these and just shoved them back down in here like this. Okay. Now, this is going to continue all the way through, and I'm going to repeat myself multiple times. Okay. The black wire is what's called the hot wire. Okay. The white wire is what's called the common wire. Hot and common. And the bare wire, or in some cases, like if I'm wiring an electrical cord, the green wire right here is your ground wire, okay? So hot, common, ground. Hot, common, ground. We're going to wire with that thinking in mind all the way through. And I'm going to help you so that you know.
So is the copper wire ground wire?
The ground wire is the bare copper. Okay?
Or green.
Or green. Okay. Now, electrical wire has to be super consistent. So if you want really consistent wire, you can pull this copper wire. In fact, I use this copper wire all the time for jewelry class because it's very consistent. It has to be. So this is what's called 14 gauge wire. This is 12 gauge wire. The smaller the number, the thicker the wire. So if I have a 0 gauge wire, it's going to be that thick. Okay. If I have a 30 gauge wire, it's going to be as thin or thinner than a human hair over here. So 14 is thinner than 12. That means 12 gauge, like in my garage where I'm running power tools and heavy duty air compressors and things like that, I've got 12 gauge wire in the wall. It will carry more electrical current than a 14 gauge wire. Okay. Most of your lighting circuits, say in your bedroom, are going to be this 14 gauge wire. It's a lighter wire, it's less expensive, it carries less current, but now if I'm running, all I'm running is LEDs, or I'm plugging a television into the wall or something, I'm never going to need more than this 14 gauge. But if I'm running tools, equipment, heavier duty stuff, then I'm going to go to 12 gauge. So if you look inside of say you go in your basement, you say you've got an unfinished basement at home that is wired in, you're going to see this wire stapled to the stud that's going through your basement, okay? Now this has to be very precise, so I know if I put this in, this thing right here is called the BNS gauge, and that is 14 gauge that's hanging on to that. It will not fit in the 13, or in the 15, sorry, and the 13, it'll just fall out. So it is precisely 14 gauge. I know if I do the same thing here, that I'm going to put that in, that's the 12 gauge, it's holding, it will not fit in the 13, and it falls out of the 11. Okay, it's very specific, and it's very specific all the way along its length. And this is why if I slow down electrical current at all, it's going to get hot because I'm trying to force more energy through a smaller conduit. Okay, so if these manufacturers created wire that had thin spots, that thin spot's going to heat up to a point where it's going to start a fire in your home. And then that electrical company is liable for all the damages, and then however many homes they put that in, they would have to rewire everything. So their manufacturing process is really, really consistent because they don't want that heat in the line. So those wires, I could have 500 feet of that and go along every 1 foot and measure, and it would be exactly 14 gauge or exactly 12 gauge. Now, there is something they do that they use in the past. So Thomas Alva Edison. This is a vintage Edison light bulb. It's kind of funny because it says vintage Edison light bulb, but it's actually LED. Okay. I had an actual vintage Edison light bulb here, and somebody dropped it on the floor.
Like from Edison, the guy who made that?
No, the Edison style bulb I had here.
That was halogen.
Yeah, it is. We'll pull that out, put it in here. Anyway, this is an incandescent bulb. These are really simple. Electricity comes in through here. It goes up, goes through this little tiny coil that's in here, goes back down and goes out here. Okay. So when this electricity gets up to this little tiny coil, it's a really, really, really fine wire. And because I'm slowing the electricity down, what's it doing? It's heating up. It's essentially creating a fire. Okay. The problem Edison had when he was building the bulb is he didn't have these encased in an inert gas, like an argon or a xenon or something like that. They were just in oxygen. And what would happen is it would oxidize, it would burn out really quick and be gone. So he figured out that if you seal them, so this inside of here has an inert gas inside of it, so when that heats up, it actually burns. There's a lot of heat coming off of that, and that heat creates light. Okay, LEDs work in a very different way, but this is a hot bulb, and I'll show you that here in a minute.
So if you feel it was like.
So that's a controlled fire, basically. That's how we get light from an incandescent bulb, it's to controlled fire. Okay, so these wires are very consistent, and so much of this is stuff you don't even need to know, but hopefully you think it's cool because you're learning stuff you didn't know. Okay, all right. This right here, this is a socket, just like these. Okay? Yeah, they do. They look like a little face, and it looks like one side's kind of winking at you. Okay? This is a special type of socket. This is a socket that would normally be hooked up to this kind of wire, because this is a very specific, this is a 20 amp circuit, so this would typically go back to a breaker in your breaker box that has a 20 amp breaker, so if anything exceeds that, that breaker is going to pop. Okay, you typically wouldn't hook this up to here because you can hook tools into one of these that demand more electricity that would start to heat up these wires. So there's a lot of specifics, but I got this because this is what's right here. Okay, and there's a reason why this looks the way it does. First of all, one of these is smaller, it's shorter, so you can't reverse the right kind of plug. You can't just flip it in here. And then that actually has a functional purpose, because there are some pieces of equipment, it's rare, you don't see them very often, but you'll have one prong going this way and the other prong going like this. So there's absolutely no way you can defeat that. You can't plug it in the wrong way. It can only go in one way. And that's why you had that horizontal thing right there.
I went to another country and their plugs were weird. You had to like go buy a specific plug.
All of this stuff I'm telling you right now is for the U.S. You get outside of the U.S., all bets are off.
Like
Different electrical.
Yeah.
Okay, so come close so I can show you this. Okay, and this is where the notes are going to come in handy. When I wire one of these outlets, okay, gold screws, silver screws, green screws. Okay, gold screws are always hot, so that's where my black wire is going to go, to the gold screws. Silver screws are always common. Green screws are always ground. Okay? Now, if you look at this, the silver side of this has this little T union. Okay? The hot side is this, the little mouth on the face here, that's the ground. Okay? So that connects to here, these connect to here, these connect to here. Okay? So this is something to remember. Hot wire, gold screw. Gold screw. Common wire, silver screw. Ground, green. So if you remember that, it makes things easy all the way through this. So hot gold, common silver, green, green, or bare green. Okay? So this thing, when I put this in the wall, now I'm going to go on, I'm going to talk about plugs. First thing I'm going to show you is the kind of plug I do not want you to buy. They have these at the hardware stores here in Ephraim. And I've asked them to actually quit selling these because these are not safe plugs. Okay. Part of the reason is there's no baffle, there's nothing blocking these two screws. So if I wire to this, there's also nothing, you can see there's just an open channel through this. There's nothing holding on to my wire. So if I do like so many people do, and I just yank on my wire to pull this out, there's nothing really to keep that wire from pulling out of here. And if I pull that wire out far enough, the electricity is going to arc across these wires and potentially start a fire, especially if your circuit breaker doesn't work. So these, they have a big old open hole like this and just plugs like this. I do not want you using.
What does it look like in one piece?
If I push this together, it just clamps down. I just really don't like these.
So those are bad.
These are bad. Okay. The other thing about this too is you notice the prongs on here, they're the same width. They're both narrow prongs. So I can plug this in this way, I can pull it out, I can plug it in that way. So it essentially destroys polarity all the way down the street.
Yeah, it's basically old,
Yeah, these are old-fashioned kind of plugs. I don't know why they even still sell these. The kind I want you to get, and they have these at Ace Hardware, they have them at Do It Best Hardware. These are Leviton brand plugs. And these plugs they're polarized plugs, okay? They have a common and a hot side. So you'll notice when you look at this, one of those prongs is wider than the other, okay? One's wider than the other, and it can only go in one way. If I pull this out and I try to flip it, I cannot plug that in. I guess if I really break the plug, I could get that to happen, but it will only go in one way. Now here's what's cool. When I open this up, silver screws, silver screw. Gold screws, gold screw. Okay. So that tells me how I need to wire going down the line, because I'm going to hook my common wire to here. I don't know, hook my hot wire to here. The nice thing about this is when this closes down, and I'll show you, I'm going to actually wire a light circuit here for you. There are pins, there are baffles and things that block so that the wires, even if you're dumb and you yank on the wire,
Like you're not.
it's going to keep them separate. But then there's also a little wall here that clamps down onto the wire and holds the wire. So even if I pull on the wire, it's pulling right here, not down here. Okay? So these are about as safe a plug as you can get for wiring things in. Now, this one right here, this is a 3-prong plug. There's no reason that you would really need one of these unless you have a really specialty light. I wouldn't even bother getting these, but just so you can see, the prongs are the same size, but it has this, okay? So it can only go in that way. You can't flip it over, it can only go in that way. Now, this is a word to the wise. If you have a plug like this, these break off occasionally.
Yeah.
You've probably all seen them. If that breaks off, still plug it in that way. Really, you shouldn't be using it because there's a ground there for a reason. Like electrical cords, all the electrical cords have that ground, okay? Because that electrical cord could get out and it could get wet. There could be some electrical shock hazard, but that thing has a ground that goes back the way it's supposed to, and it lessens the risk, okay? But if I plug this in like that and I pop this open like that, silver screws, gold screws, green screw, okay? So now you know when you buy these at the hardware store, what's inside of there. And they come in all different sizes. You can get big old heavy duty industrial looking plugs like that. Okay. That's basically just the same thing. If I unscrewed this and pulled this open, you're going to see a gold screw, a silver screw, and a green screw. Okay. So,
Are they made out of different stuff, or are they just different colors that you can?
they're just different colors. One's plated with silver, I think. Not silver, but chrome plated or whatever. So now you know from here to here to here. Do not buy these. Now, the wire coming out of your plugs can be varied quite a bit. This right here is an electrical cord wire. You'll notice these are solid wire. These are not meant to be bent all the time.
Yeah.
You bend these enough, the insulation's gonna break because it's a stiffer insulation, or the wire's gonna break, okay? These are stranded, so the stranded wire does not do what's called work hardening as easily. I mean, if you sat here and did this all day, you'd probably cause a problem. But just under normal use, you're not going to, okay? But you've got hot, common, ground.
What about the fluff?
This fluff right here, actually used to think it was Dyneema, the stuff that big ship ropes are made out of. It's actually Kevlar.
Oh.
That's Kevlar?
So that's Kevlar, yeah. Had to look that up because it feels very much like Dyneema, and it's probably very similar. But that is because these are getting pulled on.
Yeah.
It helps the tension go to this. This will not stretch. It will not stretch. You cannot break this. This is stronger than steel. Okay. There's a similar thing right in here. It looks very different, but this stuff is stronger, pound per pound, stronger than steel. Okay. So that takes the pressure off of the wires. Now, one reason why you might want one of these, this is just a 2-wire. So you could wire this into a plug similar to this. You're gonna have to have a different plug than this. So if you decide you need something like this, we need to talk, okay? But this, I could hang my light from just the cord. This, I could hang my light just from the cord, okay? Yeah, that's why you've got things like this. These drop downs, this is essentially that, okay? Just yellow, okay? Now, when we start getting into the 2-strand, so this is electrical cord wire here. This is, so this right here is 14 gauge, so it's the same gauge as this white one here. This one is 18 gauge, so it's actually thinner than these. All of these, as a matter of fact, are all 18 gauge, okay, so it's a thinner wire. This, though, because it's one of those little electrical cords that you can buy at the store where it's got the plug and the little plug unit at the other end, this is a little heavier duty because it might get stepped on. It's going to be moved quite a bit. Don't use this. I had to get after my hardware store friends because they were saying, oh, why do you have to wire a plug in? That's part of the requirement for this project is you have to wire a plug in, okay? They were just selling my students electrical cords and saying just cut off the one end and wire it in from there. That's okay, but most of the switches are not designed to work with this heavy cord, okay? So don't just go buy an electrical cord and cut the end off of it because the insulation is too thick, it's not going to work, okay? This wire right here is what I'm going to provide. I've got spools of it, I've got black, I've got white, I've got some silver, I'm going to get some more brown. So there are different colors of wire. That's the only thing I can provide though, because your lighting design starts at the plug, okay? And it goes through the wire to the switch to the socket. All of that stuff is an aesthetic decision in your design. So you need to buy the plug, the switch, the socket, the bulb, okay? And then whatever materials you need to produce your light, yes.
A switch is required for this assignment?
Yes, it is required for this assignment, okay? So, depending on your design, you're gonna buy different plugs. I do have some of this too. This is some old school looking wire, but it's not old school wire.
Yeah.
It's actually got the insulation and everything just like a new school wire. Now, the question is, that's easy to tell what hot and common is, right? There's a black one and there's a white one, and there's a green. That's easy. Okay, figure out the difference between those wires.
It's a gauge.
Nope, they're 18 gauge.
I can't even see them.
Can I see?
This one's.
It is thin wire.
and it's a-
But there's a difference between, there's a difference on the sheathing
There's
of
printing
that.
on this one.
There's printing on one, yeah, it's stamped in printing, sometimes it's actually black printing, okay?
One side's smooth, one side's.
One side's smooth, one side's ribbed.
You want us to guess which one?
You don't have to. You just need to be able to recognize the difference. Okay? So one side of the wire, and that goes for this too, one side of the wire has little ridges on it. You can drag your thumbnail over it like that and you can see the ridges. The other side is smooth, okay? Here's what it is. Hot to gold to smooth. Hot gold smooth, okay? Common, silver, ridged. Okay, so got that progression. We're 90% of the way there on polarity stuff. Okay, so as I go in here, if I open this up, I'm going to hook the wire with the ridges, the ribs running down it here, to the silver. The smooth stamped side is going to go to the gold. Okay, so everybody clear on that? So the wire now, what the wire looks like depends on your design. Any of you planning on multiple lights? More than one bulb, more than one socket?
Maybe.
Okay, because that's a whole other thing that I need to show you, and hopefully we'll have some time today. Nobody in the other class was planning on that, so I didn't even demo that for them. So if you want extra knowledge, I'll give that to you. Okay. So then we go from our cords and all of this stuff. Here back, we don't need to, I'm going to move that out of the way. Here back, we don't need to think about for design. That's already in the wall. Okay. From here forward, you can see it, so you got to design it. Okay. You got to think about, so if you've got like that white light that's in the student show right now that was made last semester, it has a white cord, a white switch, a white plug. You can imagine if that white light had a brown cord or a black cord, aesthetically it doesn't work together, so be aware of that. Okay, then we go to switches. Okay, there's all different kinds of switches. Kind of switch I'm going to recommend to you that's fairly inexpensive. It's an inline switch, and it's just a little rotary switch. I'm going to wire one of these into this system over here. Okay, so you can have a switch like this. There are also switches like this that you can use that are a toggle switch. This is a kind of a high-tech little gadget here. Inside of here you've got a circuit board. Get that to come off of there. This is a rotary dimmer switch. You would have to order these on Amazon. You cannot get these here in town. But you can see this just got a little potentiometer in here. You click it on, and then it gradually will increase or decrease the amount of lumens. I've got two of these over here that I can show you. You actually cut the wire completely, and you've got line and load here. So my cord coming in from my plug is going to go to this side. My load going out to my light is going to come out of this side. And then I just need to make sure that my polarity comes in same side, same side. Okay.
Do you need a certain bulb for those?
Yes, and I'm going to show you that here as we go on. This is, you could have this on the floor, and it's so you just go,
Nice.
those you're going to have to buy online as well.
It's
So,
funny. Those ones, my family has one, but it's for our, like old 90s Christmas tree. Yeah.
So there's all kinds of different switches, like all kinds of different switches. I told you about the young lady that wanted like 8 different bulbs and 8 different switches. She had every different kind of switch you can imagine. So
Why not all the things?
I don't know.
Funner with
I
multiple
don't know. It
switches.
got crazy. Okay, so switches. You're going to have either an inline switch or you're going to have a switch that is built into the light. Okay? This is stupid. Okay. This is stupid. But I do that just to demonstrate. If you're not going to have a switch at the socket, now here's the reasons why you might have a switch at the socket. Just blew a surprise. But if you're going to have a switch at the socket, then you need to be able to access that switch. So it can't be something that's hanging way up in the air, and it can't be something where your bulb and everything is completely contained within an object. You have to be able to reach in physically, access that switch, and switch it on and off. If you can do that with your lighting design, then it's perfectly acceptable to leave out this inline switch and just go with this switch. Okay? But if you can't reach this easily, like if you have to pull the thing off, click the switch in, put the thing back on every time you want to use that light, that's not very functional. Okay? So I would just wire these in. If you can't find these, the only place here in town that carries these is Ace Hardware. Yeah, you can buy these online though. You can buy them in sets, so if a couple of you want to go in together and order them from Amazon, get them overnight or whatever, you can get these kinds of sockets. There's so many different kinds of sockets, okay? These you can get anywhere. They've got pull chain, they've got push, they've got rotary switches, they've got all kinds of different switches for these, okay? But you have to have a switch, whether it's designed into your socket or whether it's inline, you have to have the ability to switch it, because plugging something in to turn it off on and unplugging it to turn it off is not a good idea. Okay, so you're going to have sockets. Sockets come in all different shapes and sizes and colors. This one's going to be one that's going to take some abuse. It's rubberized. It's heavy duty. The wires coming out of here are heavy duty wires. So this thing is designed to probably take a pretty powerful light bulb, and you can use this.
You can't go like this if there's a bulb in it though.
No. This one looks similar, okay? It's got the black and white hot and common cords coming out of it. But you notice that the connections here are bare and accessible. Okay? If your light is going to be around anyone who doesn't have the capability or common sense to not go touching this while this is energized, then you can't have something like this or like this. Okay, these are usually, if you go and look, if you went and took the light on the front of your garage apart, that's probably what's in there, because it's encased up inside of a thing. It doesn't matter that those are bare. Okay, but if you're going to build a light for a children's bedroom for a child, and that's just bare, bad things. Okay, you can coat and seal this with a silicone caulk or something and let that caulk set up, and it'll be protective. But I just don't even recommend these. But you also notice these right here. There, notice silver, gold, silver, gold, silver, gold. These don't need that because they've got the hot and common, okay? Hot and common. This one right here, if you want multiple, if you want 2 bulbs in the same fixture, you can utilize these. These are designed for ceiling fixtures, so they'll thread into the housing, and you can thread on one of those dishes that sits underneath here. That's what these are designed for. And then depending on the size bulb you want, silver, gold, this is what's called a candelabra bulb, the smaller base.
Okay.
So you can create a candelabra base. This one's actually a little smaller here. I don't know exactly what it is. It's not even saying on here. Yeah, it doesn't even say what size bulb that is. And then these are kind of cool because you can unscrew this top. You can split your wire, run your common side over the silver spike, run your hot side over the gold spike, and then when you clamp this down right here, it stabs your wire with those spikes and touches the copper, and you can hang these along like that, all on a single cord. Okay? All kinds of things. Now, if you have a socket like this and you want a candelabra bulb, there are actually bulbs that you can buy at Walmart that come with these, and you can just thread this into a standard A26 base, and then you've got a candelabra, or E26 to an E12. E12 is candelabra. So this is E26 on the outside here. This is E12 on the inside here. So if you want a candelabra bulb, but you can only find this kind of socket, you can do that, okay? So there are things like that. All right, so that's all the way through from the plug in the wall, cord, switch, socket. Now the socket you want to make, you got some decisions to make, because that's attractive. visually it's attractive. It's gonna pull your eye in, so if you have a very earth-toned light, and then your socket can be seen, okay? You can see it, you gotta do something about it, okay? These, you can paint. There's little cardboard things in here. Do not discard the cardboard. That is not scrap, that is safety, okay? It is there for a reason. It's non-conductive material. But I can pull the cardboard out of my housing, so say I wanna use this, but I don't want that shiny metallic yellow. Say I've got my whole light is like pastel colors or whatever. I'd pull this out, I'd pull the cardboard out of here, okay, out of there, and then I would take this, and I would paint the whole thing with whatever paint I want, whether it's black or white or pastel blue or whatever. I can paint this housing whatever color I want. And then when I put that in there, I don't have this shiny gold thing. So if I've got all white cord, all white plug, white switch, white cord, I could spray paint this a flat white or something like that, and none of it stands out. It does not attract the attention. So all the attention is on the light and the object that you've designed, okay? So just be aware of that. Now, another thing is these are all designed to have, this is all tightened down. These are all designed to work with what's called, it's kind of a funny name, but it's called lamp nipple, okay? This stuff right here, this tube right here is what's called lamp nipple. I can thread this in, it's got a hole in the middle of it, so that I can feed my wire up through this into my socket. So let's say I've got a wooden base and I want some structurally sound way of putting this into my wooden base, and I'm coating the thing with something, but I need my light to be a certain height. You can get this at the hardware store in several different lengths. So once this is all together, okay, it'll be about that tall, so my light's actually going to be about right here. So if I've got a piece that's this tall, and I don't want my light to be sitting right down in the bottom of that, I want it to be up in the center, that's what I can do, okay? And then I can drill a hole through my base, I can run a cord through there, I can run it up inside of here. It's all very clean, okay? Now, if I want to hang my light, I can also put things like this that have a hole that I could feed, and I can hang this from a cable or from a chain, so I don't have to worry about my weight hanging on my lamp cord. It is not up to code, it's not legal, so to speak, to hang your lamp from this cord. You could from these, but you cannot from these. So there's stuff called lamp chain that you can get at a hardware store. There's all different sizes and lengths. You could also use a cable or heavy duty string that would hold your light from this point, and then it's not hanging from the cord, okay? There's also versions of this where you can screw that on, screw this on, and have that distance here too, okay? So there's lots of options in your design. There's lots of threaded little pieces that go on here that can hold pieces. So let's say I've got a couple of different things that are coming off of here. I could hook them inside of here, clamp down on it. Okay, so there's lots of possibilities there, okay? So just be aware that this kind of stuff is available for potential use in your lighting design. That's where I need to sit down and talk with you. You need to have some pretty good thoughts put down, some pretty good imagery put down, and then I can make some recommendations that you might want to hook that with lamp nipple. You might want to do this way or that way. Once I have your proposals, then I can tell what's going on there, okay? Tools for this process that I'm going to demonstrate to you. These are the tools that are in my teacher box. These are not student tools here, okay? But you have all the tools you need right over in here. There are soldering irons, there's electrical tape, there's solder. There are tools that work just like the tools that I have over there. Wire strippers and pliers. these are what are called auto strippers. I'm gonna show you how these work using mine over there. They're pretty nice. But all the tools that you would need are right in that case, that Stanley tool case, all right? So, I'm gonna start off with my plug. I'm gonna open this up. Got my gold screw, my silver screw. Got my wire here that I'm gonna wire in. First thing I'm gonna use is my auto stripper here. I'm gonna strip off about 5/8 of an inch of cord, okay? And what this does is it just pops that, doesn't break any of the wire at all, cuts both sides at the same time, and removes the sheathing and exposes the bare copper wire, okay? I'm gonna pull this back just a little bit. I don't want a lot because I don't want it coming out of my plug. Now, this is critical. It seems silly that it matters which way you twist the wire. It does. If I'm looking at the end of my wire here, I'm going to twist it to the right. If I'm facing it like this, I'm twisting it over the top. So I'm twisting my wire to the right. Get it nice and snug like that. If I twist it to the left, when I put it under the screw and I start tightening the screw, it's gonna unravel, okay? But if I twist it to the right, it's not going to unravel, okay? So I've got about 5/8 of an inch of wire exposed. I have twisted it nice and tight to the right, like that. I usually like to start with my ribbed wire, okay? What I'm gonna do is I'm gonna take this wire and I'm gonna J-hook it, like that. And it's gonna go just a little bit past my insulation, okay? Just a little bit past, just like that, okay? Now, these screws right here, I need screwdriver. There are screwdrivers in the case right over there. And I'll flip this around. I'm going to unscrew this as far as it will go. It will stop. Typically with electrical stuff, those screws will stop because these are very specific screws. You don't want to take this all the way out. It stops for a reason. Okay, so I'm going to open up both sides here all the way until the screw stops. Okay, now I've got my ribbed side, and I always double check here. Ribbed side, that's the one that's hooked and ready to hang on. So I'm going to hold this right here. I'm going to pretend like that's 12 o'clock. So this is the face of a clock down here. I want my wire, my insulation side, to come in about 7 or 8 o'clock. So if you stand here and look up at the clock, I'm going to say, okay, this lower left side for me, if this is 12 o'clock, this lower left side is 7 or 8 o'clock. So I'm going to take this, I'm going to feed it onto there so that my wire starts on my lower left side, 7 or 8 o'clock, wraps around to my 5 or 6 o'clock side. Now I'm going to take this and I'm going to tighten this down as tight as I can get it. Okay? So make sure this is really, really tight. The other thing you need to pay attention to, and I want you each to look at this. So take this and hand it around. Notice where the wire comes in, where it goes out. Notice it didn't come unfrayed. Notice it's tight under that screw. But the thing I want you to notice most is that the insulation is not under the screw. My screw is not clamped down on the rubber insulation. If it's clamped down on the rubber insulation, it's likely not clamped down tight enough on the wire itself. And it can come loose or it can arc because it's not actually tight underneath that screw. So that's exactly what it should look like when you do yours. Okay. Not a lot of copper wire hanging out of there. There's very, very minimal copper wire. And that's because I cut that to the 5/8 of an inch, which was about what I needed to go around there. And it's all nice and snug. Yes?
Do we need to have a ground in our wire?
No, not necessarily. There's very few reasons why you would need a heavy wire like this with a ground. Then you would need a plug like that. But for almost all lighting design, especially LEDs, there's no ground associated with the thing, so you don't need to worry about it. This is about safety, this here. I want to inspect your wiring just to make sure that it's done exactly right. I don't want to be in the chain of burning grandma's house down. Okay, so I want to make sure, everything is wired correctly and safely. Just notice primarily that insulation is not under that screw. If it's under the screw, you've got to undo it and you've got to redo it to make sure it's not under the screw.
It's the rough side that goes in the fin.
Yep, rib side, rough side to the silver, smooth side to the gold. Okay? Now I'm going to flip this around. The same thing applies, but it's going to be funny because it's going to look like they're coming into opposite sides, which they are, but I'm looking at this, and now I'm on the gold side looking at this, and I still want my wire, so I'm going to create my little J hook here. I still want my wire to come in the 7 or 8 o'clock side. Now sometimes that wire does not like to wrap all the way around here. I grab a small screwdriver. There are small screwdrivers in the drawer over there. And I push that and I force that wire to come all the way around. And then I'm holding with my thumb right here to keep that from slipping out on me. So I'm just holding that until I can get my screwdriver into the screw here and I can turn that tight. And what will happen is if that's hanging out a little bit, as I tighten this, it's actually going to pull the wire around the screw and it's going to pull my insulation up nice and snug against the screw. There's not a lot of extra wire hanging out of here. In fact, there's no extra wire hanging out of there. And then before I close this up, I'm just going to verify smooth to the gold, rib to the silver. Now, I'm going to fold this side in, the side with the little prongs. I'll fold that side in. Then I'm going to push my wire through those little channels made by the prongs. Okay, can everybody see that? Okay. And then I'm going to push this down and I'm going to start screwing this down here. And I want to screw this down so tight that that gap closes down. Okay, so nice and snug, that gap is closed down. That means this wire is clamped right about here. Okay, so if I am not being smart and I pull on this, it's going to pull right here, not down here where the screws are. Okay, so that plug is wired in, easy. If I wasn't going through all of this stuff, if I just started wiring the circuit right at the beginning, I would have been done 20 minutes ago, easily. Okay, so now my plug. I'm not going to put my switch in yet. I'm going to wire in my socket. Now, what's wrong if I go ahead and wire this in right now?
You can't put the switch in.
Huh? No, I can put the
No,
switch
you can
in.
put the switch in.
You can?
I can.
After?
Yeah, because I'll put the switch back here. What's wrong though? What can't I put on?
it. That's...
What can't I put on if I just wire this in right now?
Your
This
is it
happens
the cover,
all the
the
time.
cardboard,
The cover?
that guy.
It happens all the time. I see people get this all wired in. They come, how's my wiring? I'm like, it's great, except.
You're missing a little guy.
So anything that this wire has to feed through, whether it's a piece of lamp nipple and it has to feed up into this here, like that, that's all got to be on there before I wire this on, or I can't put that on. Okay, it's not a big deal. It's just kind of funny when I have to walk over and say, yeah, this needs to go on first. Okay. So once that's on, okay, now I'm going to strip this a different way. I used the auto strippers on the other side. I'm going to strip this side using this wire stripper tool here. Okay, so I'm going to pull this back just a little bit. Okay, and then I'm going to take this. And this thing has 18, 20, 16, 18, 14, 16. It's got the wire gauges on here. The 1820 is too small for me. The 1618 is, I usually go a couple sizes larger so I could technically, this is 18 gauge wire, I could technically use the first opening. But I'm gonna go to the third one because that's still gonna cut my insulation, and then I'm going to just pull on my wire on this side and it's going to pull the insulation off. The reason I go to the larger one is because I don't want to remove copper wires right here, okay? They're stranded wires. What happens if I remove very many of those strands?
Won't work.
It's gonna.
You glanced in the right direction.
Oh, it's gonna catch on fire.
Yeah.
Yeah.
You glanced right there.
Gonna lose energy.
Yeah. I'm increasing the resistance and I'm making it potential for heat to build up there. It's not likely, but I don't want to do anything that could potentially become a problem. So I go to this and it still strips my wire, but it doesn't take any wires with it. There's no copper wires in there. If I went to that 18, it's likely that I would see copper wire in my sheathing here. So you can strip the wires both ways. One way I do not recommend, I see people do this all the time where they'll just kind of cut into there and pull it off. That's not a good way to do this, okay? So now I've got my wires here. They're twisted to the right, okay? And I'm gonna find, there's my smooth, there's my ribs right there. I'm gonna J-hook that just past the insulation, okay? That's it. All this stuff, believe it or not, is critical. So now I'm gonna take this. These will come out all the way, so you wanna be careful. But I've got my rib side hooked, double checking just to make sure. And then same thing, I'm gonna hold this up. The threads are 12 o'clock. I'm gonna come in 8 o'clock, wrap around to 6, right there. And then I could just hold that and I'm gonna snug this down all the way. There's little pins on either side of this screw that are bent out just a little bit. They're designed to kind of keep the wire down underneath there, okay? And that's okay. Sometimes it will squeeze the wire out a little bit, but it's under there nice and snug. So now I'm gonna do the same thing on this side. I'm gonna hook that over right here, and this sometimes is a pain. Get that wrapped around there. Now that wire popped clear up here. That's where I'm going to grab my little screwdriver and I'm going to just push that down underneath the screw. Okay. Then I'm going to snug this up. It's not a big deal if some of the wires come out just a little bit. Some of those came out just a little bit. So it's all nice and hooked up. Now, I can close this up. These things are not designed to be taken apart. You can take them apart. I took this one apart this morning. Okay? There are little nubs right here that fit into these spaces in the cardboard right here. It will not go on otherwise. I can try putting it on all the way around until it gets to there. It won't. That makes sure that it's holding my electrical connections next to the cardboard, because this is conductive material. If that cardboard is not there, these are going to arc against here and pop your circuit breaker every time you turn your light on. Now, I could close this all up, but I'm not absolutely certain everything's working. So, I can use this little doodad right here. This is called a continuity tester. You can buy, if you've got a voltmeter and know how to use it, they actually have a sound. They'll beep to tell you that there's continuity. That means that there's a connection from here to all the way to here on both things, okay? And what will happen, this little light will come on when I have continuity. So I'm going to clip on the wider prong, which is
the ground. It's the silver.
No, it's the common.
the
The
wide
common.
is the common. So what side of this do you think is going to light up? Just curious.
It's
The
the
Other side.
Huh?
The other
Is it going to be
side.
the little pin or the threads?
It'd be the thread.
The threads?
No, it's gonna be the
Ding, 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 ding.
threads. Okay.
The center is the hot, and notice it's not lighting up because I'm not put to that prong. Okay, so I put that on the hot and
It works.
it lights up. So I know I've got continuity all the way through. Okay, so now what I'm going to do is I'm going to push this. Now some people will tie a little knot right here. That is okay. It's not bad for them. In fact, it's good for them. It's hard to get this base on when you've got a big old knot of wire in there. So I usually don't, but it's not a bad idea. Now you heard that clip into place. Now if I put a light bulb in this and I plug it in, the light bulb's going to come on. I know that because I've done the continuity testing. Okay? But now I'm gonna ruin everything. Hopefully ruin everything that I've just done.
He's getting his big chair out.
Get my chair out. What I'm gonna do is I'm gonna come back here, I'm gonna figure out where I want my switch. Now, you want your switch somewhere easily accessible. If you've got your switch clear down on the floor, so you gotta bend over every time to switch it, that's not great. You could probably put it off, like if you're planning on this being on an end table and it goes over and just drops off the end, just so you don't have a switch sitting right on the table, you could drop it off over the side or something like that, but you want it accessible. Now a switch is especially important if you've got a light that's hanging from the ceiling. You can just have the switch at about arm's level where you can go over and you can rotary switch your light on or off, depending. All right, so now I'm going to put a switch in. I'm going to put this little rotary switch, and if you look at the rotary switch here, okay, if I pull this one apart right here, there's this little channel.
Does it open on? Yeah,
Okay, there's this little channel right here going through the middle, and I can pass this around. And then there's a wall on one side, and there's a channel that circumvents this, okay? The way a rotary switch works is there's little spikes right here and here. Those spikes are designed to stab the wire that I cut, the one that's getting blocked by the wall, okay? They will stab that on either side of the break. And then this little rotary thing here, when you hear it click, it's doing one of two things, okay? It's either opening or closing the circuit. And what that is those little brass spikes there, and I'm gonna hand this around so you can all see it. Little brass spikes there are hooked to a little spring-loaded kind of wire thing inside of there. And when I click it, the circuit opens, these little plates separate, and the electrical current stops. When I click it again, the plates touch, and it continues the circuit. So it's a really simple thing.
it's like a hose.
Yeah, so I'll hand this around so you can look at that. That's the kind of switch I'm recommending you get. Now, something to be aware of. There's a little tiny nut right here. The screw does not come out. That little tiny nut comes out, and if it drops on the floor, good luck ever finding it, because it is tiny. So this is where I'm going to use my small screwdriver. It is a slot head screwdriver. And I'm going to loosen this. And notice I'm holding it over my electrical tape so that my little nut drops down into there. And I know where it is because it's a heck of a lot easier to figure out where the electrical tip is. Yeah, it's very tiny. So you can imagine this falling onto the floor and into one of these cracks. In fact, I bet you if you went along these cracks with a cleaned them all out completely, you probably find a few of those. It's not worth it though. So now I'm going to open this up. There's my little spikes. There's my little channel and my switch. So I'm going to come down here, and this is where you've got to be very careful. I'm going to take my utility knife and that seam right between the two wires, just wherever I decide I'm going to put my switch. I'm going to very carefully cut that. If I veer to one side or the other, I'm going to see copper in here when I open this up, okay? Just want to make sure I don't see any copper in there, okay? So I've done that. Now here's where I ruin everything. I always like to cut the hot side. It doesn't matter which side you cut, but I always like to cut the hot side, so I'm going to go right in the middle of that opening right there, and I just broke my circuit. Now my light will not come on, okay? So I'm going to take this little channel right here, and the wall is facing me, so I'm going to push this all down in. So when this is all put back together, this wheel is sitting right on top of that wall. Those pieces of cord cannot touch each other, okay? They are permanently separated by that little wall, okay? And this is kind of foolproof because you can't flip it. You can't have your solid wire going over the wall. It just won't work, okay? So I've got that all pushed in. And what that does is, as long as I haven't twisted this in some weird way, the side that is going to get stabbed by those little spikes is my broken wire side, my hot side. There are little pegs on this. If you look at that, there are little pegs that fit in the holes there. And it doesn't matter which way you put it in, those spikes will stab the same side. And then I'm going to push this in all the way down like that. Then I'm going to take my little nut and I'm gonna put it in the space for it. It's shaped like the nut, so I don't have to have a wrench. And then I'm gonna just tighten this down. You wanna be careful. These are fragile. They can get messed up. But I wanna take this and I wanna clamp that until it's snug and that's all closed, and I wanna make sure that my switch works. Now, sometimes these switches are faulty, or sometimes the prongs get bent funny and they don't stab. So this is where this thing can be really handy. So if I want to test this, which side am I going to hook this up to based on everything I just
The
did?
comments. Oh,
No.
this is the.
The hot side.
I don't know anymore.
The hot side.
I was wrong the first
Because this
time.
one you
I
cut.
was-
The hot side, yeah. So if I touch this and it lights up right now, then I know it works. It's not working.
Turn the switch
Uh-oh.
on.
But maybe if I do this, oh look,
Oh.
there's light. My wiring circuit is done. So now I can come over here and I can
Light
spin
bulb.
this bulb into here. This is my big incandescent bulb. This thing's probably, at least 100 watts.
100 like watts or 100 theoretical watts?
100 watts. This is, okay.
Whoa. My eyes.
Intense, but intense, not just in light. Hold your hand close to that. Don't touch it.
It's warm.
It's warm. Okay.
But those are the pretty lights.
Okay.
Oh, but I can't see.
Anybody ever have an easy bake oven?
Yes.
Yes.
What
I
do they
can't
use
say.
to cook the cookies
The light
and the
bulb.
brownies? A light bulb. And the light bulb isn't nearly as strong as this bulb. This bulb gets hot enough that it
Is that
can
why
give me
those are
severe burns.
discontinued?
Yeah. They're very
the light?
inefficient.
Oh yeah.
They're super inefficient.
It's
And all of that heat
Yes.
energy that's burning off right now,
I can't see.
it's not really doing much. Yeah, that's getting uncomfortably
I have one in my
hot
room
right
with
now.
the
That's my Christmas
with the
tree.
switch that goes on the light
Yeah,
bulb.
so
So
if
you have to be
you-
really careful not to touch it when you're using it.
Dang, I should have done that.
Someone get a lampshade.
That is getting so hot that if I touch this right now, it would burn me. I would get a second-degree burn from this. It's extremely hot. Okay, so incandescent bulbs. Are you going to want to use this incandescent bulb with paper products?
Nope.
No.
With cardboard or wood or whatever? No, probably not.
I do my
Unless
Boston, yeah.
unless there's a significant distance. So if I've got a big old light and this has a significant distance and it's not enclosed, if you put this in an enclosed space with anything flammable, stuff's gonna start on fire. If you put this in an enclosed space with metal around the edges, the metal is going to get hot enough to burn you. Okay. If I put an enclosed space and put a frying pan on top of this, I could cook an egg.
That's
with
what
this bulb.
those
Okay.
wax.
I
Now,
don't think you'll dry an egg.
Those.
yeah, you can use those. Now, the one thing that is really good about an incandescent bulb, and this is a specific kind of incandescent bulb because it's clear. There are diffuse bulbs like this, okay? That diffusing material is designed to break up the direct wavelengths of light and soften the light. This is a harsh light, but harsh light can be really nice
You know what?
if I'm
Something-
trying to cast shadows. See the shadows?
You get a harsh light without incandescent bulb.
It's hard, okay?
Oh, yeah.
But if I want to create shadows and utilize the shadows, you can see that throws the shadows quite a distance.
I need that light.
Same.
Okay?
Dang
You
it.
can even see
It's
the
just gonna light
shadows.
everything on
You
fire.
can even see the shadows. See the shadows clear on the far wall.
Yeah.
Okay? So this will throw shadows. So there's a lot of lights that you see on
Is there a different
Pinterest.
one that can do that?
Uh,
Or is that the only one?
that's going to give you the most intense, crisp light.
Well,
Alright, we need
I-
that crispy light.
Well, how close does the material need to be for the light
So
bulb?
that is something
Like,
to be
if you give it like a
aware
good
of.
foot,
I don't
I'm
even
pretty sure
wanna
it'll be fine.
unscrew that at the moment because it's so,
So hot.
stinking hot. Okay, but let's see. Other bulbs will cast a shadow, like this one right here.
Does that one get hot?
UV.
Yeah, this will cast a shadow, but it's very subtle, really,
Yeah.
really subtle. Now let's just here's a little tiny incandescent bulb right here. Oh, and it's busted. Dang it! Can't even get these anymore. so I
If
think.
you turn it on, will it explode?
Yes, it would burn out really quick. And it's not terribly safe, so.
Oh.
Okay. I might have another little incandescent bulb in here.
The weed bowl.
I've got a little incandescent bulb.
Yay!
Okay. So this will do the same thing. It's just not nearly as intense and not nearly the same level of heat.
So it warms that thing on fire?
Can still set things on fire.
Yes, it
Heat
can.
is heat no matter what.
Yeah.
Oh, what is
But-
that on fire?
If you look, see, there's still a very crisp shadow to this. So if you want really the most crisp shadows, you're going to need a clear incandescent bulb like this, okay? Because this one, this is because I don't have the box for it. This is either a halogen, which is similar, or an incandescent, but it is one of those types. This one now, it's diffuse light. This one's generating heat immediately. This is 43 watts. So, but you notice it's casting a shadow, but it's a very soft shadow. Very, very soft shadow. So if you want to cast shadows, you need a clear bulb. There are some LEDs that will do it, but they're hard to find.
So do you prefer a white light to cast shadows or more warm light?
For cast shadows, it doesn't matter.
It doesn't matter?
It doesn't matter. Either one will cast shadows as long as it's that incandescent. You might be able to. Technically, yes. I think you could probably still find them on eBay and stuff like that. Now this thing right here, that's a compact fluorescent. I stopped liking these because when I would turn on my porch lights in winter, I thought they were burned out because these things are dependent on heat. They actually heat up. So when I first turn on my porch lights, there's no instant heat. Notice how this is getting brighter? The mercury molecules in here are getting excited. There's not an actual wire that's going through here, it's electrified gas. Okay. And this
Metal.
is gradually going to
Literally.
build up to its full lumens. But it takes a while. See how it's gradually creeping up and it's still almost dark up here? That is creeping up. And this will still generate heat. There is heat coming off of this, but not nearly as much heat as comes off of an incandescent bulb. These, I don't even know if you can get these anywhere anymore. I think these are these have gone the way of the dinosaurs. You can still find halogen bulbs occasionally, but
I can't see
yeah.
anything.
Yeah, I'm blinding all of you. Now, I do have some bulbs in here. Let's see if I can find it. All right, this one right here. This is an LED. This is a dimmable LED, so let's put it on a dimmer switch. Okay. This is a dimmable LED that is 1200 lumens. Okay. Now, a lot of people think LEDs don't generate heat. If they're using a lot of electricity, they will generate heat. It's just a natural byproduct. Okay. Oh, look, that's 1200 lumens. That's pretty bright, right?
No.
My eyes!
Out of the sun, possibly.
Now, you do have to
Sunglasses.
look, and on the bulbs, on the packaging, it will say dimmable or non-dimmable. So it will have it on here somewhere. Where is it? I know it's on here. Anyway, dimmable, right there. So this is dimmable. Not every LED is dimmable. Okay, so you want to make sure that you find a dimmable bulb if you're going to use a dimmer switch. Okay. Anyway, so this housing right here, that's ceramic. That's plastic.
Oh.
Okay? You can't do that with regular. If I did that with that bulb, okay? Or this one. There are some LEDs that are glass. Okay, so this is not going to heat up at all. I could put this up against my face. That's going to get hot.
Yeah.
Okay, so I need to be aware of that. Now, there are some cool LED bulbs, so let's pull this, and this is what's cool. This is how you can tell if it's a high-tech bulb, because I'll pull this out. This is an LED bulb, but if you look down in the bottom of here, there's basically a microchip, a computer. There's an electrical.
It's a
board.
smart bulb.
It's a smart bulb. So I can put this in here now. Okay, and this one is, so if I look at my lighting facts on the back, this is a 2200 Kelvin. So considered kind of an amber light, but it's going to be a very warm light. Okay.
Oh.
Okay.
That's pretty.
So that's its full intensity. So
That's really pretty.
that is 400 lumens. Okay, that's its full intensity. And then if I've got a dimmer switch, I can drop it down. So if it's a really romantic evening, you know, it's amber light, you know, you look at it,
I'm feeling romantic.
yeah, that's when you play the slow dance music.
It's like those wedding lights at nighttime. That's like that time.
So that's 2200 Kelvin. This is 2175. This is a true amber light here, and this is dimmable. So
Whoa.
you can see that. And this one I don't remember.
It's so pretty.
Remember exactly what.
All lights are
There's
pretty
so
colorful.
many different kinds, but
Ooh.
okay. So there are lights. If you go to Ace, they've got a bunch of lights that have all different kinds of interiors like this.
Yeah.
Okay. Don't design your light around this, but if that light works, say you're doing a spirally linear design, why not have your bulb echo that a little bit? Okay. But I can turn that up, so that's full intensity. But you can see how warm that is. That's this is like an accent light for a family room or something like that, where it's a nice evening and you want to just be chill. Okay, that's the kind of light that you're going to have in there. But you can also make it even more chill. So LED technology. I've been teaching this project since before LEDs were a thing. And LED technology has revolutionized what is possible for us. There's so many different things that we can do. Okay. So we can do something like that.
Colors. I love the
I don't know
colors.
if this is a color bulb or not.
Are there any colors that it doesn't have?
I could go out to Burning Man.
You just bring your own generator.
These are glass, so I've got to be careful with them. But there's some cool possibilities with this. I had a student, light blends. I had a student that did a lighting design that had this color light, and then a white version of this. That was a let me see. That was a 5,000 Kelvin. I think the one that's in my hand is not 5,000
I
Kelvin.
think it's
But I
done.
do have
I think the demo's done.
Just a bisexual lighting bulb.
Here's some 5,000 Kelvin bulbs here. And it has